Hi guys, in this lesson we're going to cover the pages 328 and 329 in your science textbook, still in the chapter on answering the question, how do scientists draw conclusions? And so we've talked about several things that they do and in the previous videos. In this one we're going to talk about go further. Once an experiment is complete, scientists use what they learn. The results of an experiment can become part of the background research other scientists use for future experiments. An experiment may lead to new questions to test. Scientists may also think of better ways to do a test. Suppose you wanted to get a more precise measurement of how high the ball would bounce on wood. How would you change the experiment? And one of the ways, you may have come up with a different answer, but one of the ways, if you're struggling with this one, is that you could say, I would do more trials to get a larger set of data. Can you see that okay? It's kind of shiny. So that says, I would do more trials to get a larger set of data. Think back to the bouncing ball experiment. The original question was how high a ball would bounce on different surfaces. The hypothesis was that a rubber surface would make the ball bounce higher. The conclusion was a wood surface made the ball bounce higher. The completed experiment might raise questions about how other surfaces would affect the ball, or it may raise questions about the ball itself. Does the ball bounce differently if it's hot or cold? How might it bounce compared to other balls? So in number 11, it's asking us to revise. Suppose you wanted to perform 3 trials to test how high a ball bounced if it was at a cooler temperature. How might you organize your results? And then we're supposed to complete the table and circle the independent variables in the completed table. So in this column, we would write the word ball. And we would do 2 different types of balls. We're going to do one that's room temperature and then one that has been refrigerated. So right across here, though, we're going to write table tennis, ball, bounce, height. Now, if you choose to do this experiment on your own at home, you may choose to use a rubber ball or a foam ball, whatever you might have, and you can either measure that in centimeters or you can measure it in inches if you want to use. If you have a yardstick, then you can measure it in inches. If you have a meter stick, then you're going to measure it in centimeters. Okay, so down here, we're going to put room temperature. Now, if you have 2 balls that are identical, you could do this test at the same time. And you could do your test with a room temperature ball and while the other one is refrigerated, or you could complete your trials with the ball at room temperature, then refrigerate it for a couple of hours and come back and do your next set of trials. Okay, so in trial 1, we're going to have centimeters or the height that it bounced. This one will be for trial 2. And then this one will be for trial 3. So if you actually want to complete this experiment, you can. But when it says here to circle the independent variables, this right here, these 2 things here, are the independent variables, because they're what we're determining. We're using a room temperature ball, and we're using a refrigerated ball. So I may actually, if I have a chance today, this afternoon, come back and actually perform this trial and see what I can find out about that. I should at least have a tennis ball around here somewhere that we could try that with. So we'll see. If any of you do that experiment on your own at home, I would love to see video showing that. So on page 329, we have an activity called Do the Math. We are interpreting data. And interpret data means that we take that data and we make some decisions about it. We look at it and we understand it and we show that we understand what it means. So 3 different students tried the experiment with the table tennis ball. They tested materials to see which caused the ball to bounce highest. And this chart here, or table, shows their results. You've got the material, carpet, wood, and rubber. That's the rubber mat. This is student A's results. This is student B's results. And this is student C's results. What might account for the different results? So if you notice right here, the carpet, student A and student C have close to the same answers, but student B had 12 centimeters. So if we look at that, it could be that the student B's carpet might have been more flat and not plush, like it might not be fuzzy carpet. So that might be the difference in the results there. And it could also be the kind of ball that student B is using, the size of, well, I don't know, table tennis ball should be the same, but for some reason, student B's results with the carpet and with the rubber mat are pretty high, pretty significantly higher than student A and student C. So one of the things that might happen is that it might have been that the student B pushed the ball instead of dropping it. So students may have pushed the ball instead of dropping it. What question were students trying to answer? Well, they were trying to answer which material causes the ball to bounce the highest. We might say which material or surface causes the ball to bounce the highest. The question that it's asking us is what question, so our first answer needs to be in the form of a question. And then secondly, what can they conclude? Table tennis balls bounce higher on wood surfaces. So everybody, it doesn't matter, the differences in carpet and rubber mat are significantly lower than a wood surface in every situation. And so they can conclude that table tennis balls bounce higher on wood surfaces. And if you think about it, that makes perfect sense. Number 13, compare and contrast. How is evidence different from an inference? Okay, and the answer here is that evidence is an observation that's made, and inference is a conclusion drawn from that observation. So evidence is an observation that is made. An inference is a conclusion drawn from that observation. So these everything in the table shows us evidence, okay? This is all evidence. And the fact that we can say that table tennis balls bounce higher on wood surfaces is our inference, okay? I hope that makes sense. So evaluate. Why is it important to do an experiment the same way each time? And the answer to that is so that a repeated experiment can produce similar results. So that a repeated experiment can produce similar results. And I just realized that we forgot to do 12 over here. This scientist is testing a pesticide on plants in a laboratory. When this experiment is complete, how might it lead to a new experiment? And the answer to that question would be that the scientist might test the pesticide outdoors, or he or she might test it on different plants. And so we will say the scientist may test the pesticide outdoors or on different plants. All right, and there we go. Good job, guys.